My name's Phill Holland. I'm a consultant and programmer for Holland Numerics Limited. We're a small consultancy dealing with SAS development and training. I've personally been using SAS since 1981 and have been producing graphs for most of that time, but most recently I've been using the ODS templates to produce SAS graphs. And it is so much easier than the old method of SAS graph production. Okay, next slide please. What I'm going to do is actually do two developments from scratch of templates for graphs which you can't do directly either in the ODS graphics designer or by default with particular items in the templates. The split axis graph, if you consider a situation which occurs occasionally in health economics where you have a period of time where you have a diagnosis of a condition and then a period where nothing happens and then another period at a later date where there's a lot of activity, sometimes patient journey from diagnosis to death, where most of the costs and interesting bits of information are actually at either end and not in the middle. You might in that circumstance want to do a graph where the central section of the graph is much too empty and you just want to cut the axis and bring the two sections together so they're closer to each other for easier comparison. That's a little bit difficult to do with templates directly. So what I'm going to do is actually show you how you could develop a template to produce a graph which will produce something that was helpful to you. I'm also going to do a similar sort of thing where you've got a bar chart where you have some very tall bars and a lot of smaller bars as well. I mean, you know that the tall bars are so much taller than the original, but you're not necessarily interested in a comparison of high and low so much as the detail at each level. So you can split the y-axis, so you just bring the tall bars down. So that will work on broadly the same techniques as we've used for the x-axis split. And then we'll look at some summary and conclusions. Next slide please. This is a familiar piece of code to anyone that's seen any of my previous presentations. Again, with the predict greater than 400 just to give a little bit of variety in the data that's there. And I've used visitNum for the quarters to make it clinical developer friendly. Okay, thank you. You don't need to look in detail at this. What I'm going to do is create three graphs next to each other in a lattice. Each graph will actually have the same data plotted into it, but I'm going to limit the left and right hand x values to specify each section. So I don't have to do anything different in each of the blocks. All I'm dealing with is changing the axis at the bottom to specify where the data is. I'm going to rotate the y-axis label and then put in optionally 2 titles, 2 footnotes and 2 horizontal reference lines which can be switched on and off. Okay, next please. This presentation is less about technical details and more about the need for planning. And it doesn't matter where you plan, and if you look carefully you'll see that that's actually a drawing on the back of an envelope. The key is you need to have something in your mind that you can refer back to as you're doing an iterative development. So maybe as a programmer you ought to have a stack of envelopes next to you on your desk so you've got something to draw on. But as you see, I've got two basic graph blocks with a gap in the middle. The lines aren't necessarily all going to be there. The red lines in particular are just marking where the central block will be. We'll remove those lines. And we've got the footnotes down in the corner, we've got the titles at the top, and the rotated x-axis label, and the reference lines that go through the gap. That's important. Okay, next slide please. So we don't want to do it all in one go because we may not know what we've done to make a particular change that's occurred. So if you do it nice and simply, what we're going to do is 3 boxes, a large one, a narrow one, and a large one, and then draw the same graph in each box, and then specify axis labels only where they're going to be important. So in other words, the x-axis at the bottom and the y-axis on the left-hand side, even though each box could have its own axes. And then the optional reference lines right the way through. So next slide please. Right, some basic template code which is going to be pretty constant throughout. We've got proc template statement, the define statement, and you'll notice I've got an A there, split plot underscore A. This is merely to indicate the version of the template that we're looking at. And you'll see in the graph I'll be specifying that template, and we're actually going to go through 6 different versions until we get to the final one. So we'll end up at F with a bit of luck. Right, below we want to specify a lattice layout with 3 columns and 1 row, and I've put the column weights as 45%, 10% and 45%. It's a starting point so we can see what it looks like. And this time the row data range is union all, which means we've got exactly the same y-axis all the way across the 3 boxes. Next slide please. Now we do an overlay for each of the graphs. So here we're specifying the x-axis with a label. We're specifying the y-axis with a label, and there's various bits about wall display and opaque. This is just to make sure that it's see-through, so you can see the colour of the page behind. You could actually fill it in if you wanted, but in this case we just want it blank. And then we've got a series plot and a scatter plot which we're putting into this graph area. Now the extra part is the linear ops in the x-axis specification. We've got a maximum value which is specified as xmax1. In other words, box 1, that's the maximum value, and we're not going to plot anything beyond that value. Remember that because you'll see it in later sections. And finally there's a couple of reference lines, and you'll see this particular bit of code in every single layout section. Next slide please. This is the middle box. Now we don't really want a great deal in here. We've still got the reference lines which are the same. At the top we've not got any label for the x-axis, but we have got view min, which is the maximum of the previous box, and sorry, x max for view min, and x min, which is the minimum of the box on the right hand side, as the maximum value. So in other words, we've got a block which is going to get squeezed in. We don't actually need all of the plots, we just need enough of the plots to make sure that it fills in the space. So we have a series plot there which we're going to draw, but as we go on later we'll actually hide that. It'll still be there, but we can hide it. Okay, next please. Finally, the right hand one, we're interested in cutting the data at the minimum value. We're not interested in cutting the maximum. We'll let it work out where the axis should go. And again we've got the series plot and scatter plot there. In each of the previous, in this case, we're only going to display lines but no labels on the y-axis. And again the reference lines as before. Next slide please. Finally, just to tidy it all off, the end of the template, we've got the end of the layout for the lattice and 2 footnote statements. Now we could put more footnote statements in there if we wanted, because they'll only be displayed if we put in the parameter that gives it a non-missing value. And then end graph to tidy it up, and then we run it. Thank you. Next slide. And this is the SG render statement to actually produce it. Notice the graphics split plot A, which is the code for that particular version. We haven't actually specified any, we specified just the one intercept, so there'd be just one line through. But because of the way that the reference lines were set up, if you don't put a value in, you don't get it. Okay, and the Xmax and Xmin values are where we're going to cut the data. The data itself there is quite a bit of data there, and so the gap is actually relatively small. But it could be as large as you want, and you specify it in those values. Okay, thank you. Next slide. And you get something that looks like that, which is not wonderfully close to what we were looking for, but you can see that it's there is a split, and it's scaled up the graphs on either side. Not exactly ideal, but what would be nice on the x-axis is in that gap to actually put some tick marks to show that the axis is continuing, and also to remove the y-axes from the middle, which are getting in the way of the graph. So if we go to the next slide, please. So first of all, we'll remove the y-axes, and that's in the second and third boxes. We change the display equals line to display equals none. Nice and simple. And then we want to put ticks on the on the x-axis in the second box, so we change display equals none to display equals ticks, and it will just put the ticks in. Okay, next slide. Right, that's the new version. Now, allowing for the fact that that box in the middle is actually bigger than we will eventually have it. So the ticks will be a little bit closer together when we've done that. It's not quite right. What we wanted was a box all the way around the graph. So we need to put in top axes for the x-axis and right-hand y-axis on the right-hand box. And we also want to remove some gaps in the x-axis as well. So on the next slide, we've got display secondary, which the primary axis is for the y on the left-hand side, but the secondary axis is on the right-hand side of a graph. So this is why it's display secondary equals line for the third y box, and also for the first and second on the x-axis. You'll see that the lines will appear in the appropriate places. Now, to make sure that everything gets squished up nicely in the middle, so we don't have too much space in between, there are some parameters which are threshold min, which we set to 0, and offset min, which we set to auto compress. And what that will do is it will push the graph right to the edge of the box, so there won't be any space in between, which makes it a lot tidier, and it should flow more nicely in between. And we do that for both minimum and maximum values on the x-axis. Okay, next slide, please. Right, it's starting to look a bit better. It's not quite right, because we specified 45% for the right-hand box and 45% for the left-hand box. But we've got all the axis stuff in the left-hand box, which is using up some of the graph space. And it would be nice if you could actually have the graph areas the same size to make it feel a bit more balanced. So what we can do is create another graph panel on the left-hand side, which only has the y-axis in. Doesn't have anything else, and so that will become a little strip which will size appropriately, and then we can have two larger boxes of the same size with just graph in, and then a little gap in the middle, which will be the split. Okay, and then the other thing before that is to hide the graph line in the middle, so it is truly a gap rather than a line getting in the way. Next slide, please. Okay, so we're changing from 3 columns to 4 columns, and with a little bit of experimentation you'll realize it's about 15% for the left hand side, and if we make it 5% in the middle, that leaves us 80% to divide up between the other 2 boxes. So we haven't changed the graphs that much, we're just squashed a bit in the middle. And then, just to make sure that we can't see the plot in the gap in the middle, we change it to transparent by setting data transparency equals 1. It's a value that can go from 0 to 1. 0 is completely visible, 1 is completely invisible, and then you can actually have sort of faded lines in between should you want to. And you might want to do that for reference lines to have something like 50%. So it's a faint line that goes through the graph. Okay, next please. We also want to create this new panel on the left hand side. So we specify, we change the second one to not have a label and therefore display none, so there's no axis line as well. And the same in the second box. In the first box we need to put a transparent plot as well. And that is nearly finished. It's not quite finished because it has the graph very, very close to the edge. And so what you need to do is just open it up with a little bit of padding, top and bottom, but also on the far right and the far left hand sides, just to move it away from the axes. Next slide please. And that's using the pad statement. And you can see the first overlay, we're padding on the left hand side, top and bottom, but not on the right. And then the ones in the middle, we're just interested top and bottom. And then the right hand one, we padded on the right, top and bottom, but not the left. And hopefully you'll be able to see in the next slide please. And you see it has moved in a little bit. You may need to compare the two slides to actually see exactly how much it's moved, but it does, to me, feel a lot more comfortable with that particular sizing. Okay, next slide please. Okay, let's do the same thing with the bar chart. Now, when you're counting the panels, when you're splitting it across a row, they go from left to right. So panel 1 is the left hand one, and then finally panel 4 was the right hand one. When you're doing it on a y-axis, it starts at the top and works down. So you just have to be aware of that. Whereas we were looking at changing things for the first panel when we're adding the y column in, the x, you'll actually do it at the bottom. So you add an extra panel for the x-axis. But this is pretty much the same. You don't need to read it in great detail. We'll go to the next slide. In true write it on the back of an envelope, I've drawn this graph on the back of an envelope too. And in the same way, we've got the reference lines which are sitting behind the graphs, and then a gap in the middle which is splitting the individual bars. And broadly the same size of box for top and bottom sections. Okay, next please. So draft version again, we'll just start with 3 boxes where the first and third are deeper than the second one with a common axis. Again, the reference line, it says across all boxes, but in fact it will appear in whichever box is appropriate. And then we're drawing the same graph in each one, but of course setting data ranges for each area. Okay, thank you. Next slide, please. Again, the graph, we're using split V-bar this time. And again, parameters as we've seen before. And this time we're doing row weights rather than column weights, and we've got 3 rows and 1 column. And the column data range means that we've got common x-axis in each of the boxes. Okay, next, please. Right, we're using a bar chart this time, and we're specifying that the orientation is vertical, and we're summing the values. But in fact, what we're putting into this data is actually a single value anyway, so the sum is really secondary. We want the Y labels in, but we're only putting the label itself on the first box. All the other boxes will be left blank. And then the reference lines, if they happen to be within the range which is specified by view min and view max for the Y. next please. The middle section, we're specifying minimum and maximum this time, and we've got a bar chart in there too. And again, the reference lines at the bottom, but other than that, there's no X option because other than the line to specify where the boxes finish. Next, please. And finally, the bottom one, which actually has the X-axis in. Again, another bar chart, reference lines as before, and specifying view max there just to specify where the data stops. Okay, next slide, please. And finally, you've seen this before, it's making sure we're closing off the template layout with the footnotes. Thank you. Next slide. And this is how you would call it. And what you specify are the intercepts, the minimum and maximum, and the various values. And very similar to the code that we showed before for the line plot. Thank you. Next slide. And you get something like that. Now, it's actually quite interesting. You can see some of the features of the individual graph boxes by the gaps. And that's where we were looking at the threshold minimum and maximum values. That is actually demonstrating what those values are actually doing to compress the data. So what do we need to do from here? So we need to remove the axes in the middle because they're getting in the way, and only show ticks on the y-axis where there's a gap. So if we do that, next slide please. And again, we're just changing line to none for the x-axis, and for the y-axis we're changing none and replacing it with ticks. Thank you. This is a problem. We've lost the gap. It's actually there, but because we're still drawing a plot in there, it's pushed it right the way out to the edge, which is not wonderfully helpful, but we'll deal with that. We need to add some axes around the box. So in other words, the top of the graph itself needs a line across, and we also need a line down the right-hand side. So we're going to need to add that in, and also there's some gaps which you can't see because they've merged together, but we'll need to deal with in the middle. So if you can go to the next one, and you'll see this is fairly similar, except instead of specifying, and I've just noticed a mistake in that, the second one, display x-axis ops, not y-axis. I'm sorry about that. Again, threshold, minimum, maximum set to 0. Okay, next slide please. Right, we still haven't got shortly. We've got dissimilar size boxes, so what we're going to do is add a new box with just the x-axis in and all the labels. It doesn't need to be as big as when we did it with the y, because the numbers are not as wide. So that's sorry, not as deep in this case. So that will make things a little bit easier. And we'll also be hiding the bars in the gap, so you'll suddenly see a gap appear, all being well. So next slide, please. So we've got an extra force layout overlay which has all the details of the bottom axis. We're changing the sizes, so we've just got 12% for the axis this time. Again, 5% in the middle, which means we've got a bit more space for the graph in the center, which is why it's 41.5%. Okay. And next slide, please. And again, we need to fiddle with the third layout to remove the X label and make it display equals none. And then finally, we can change the bar chart to a series plot, because we're going to make it change the series plot to a bar chart with transparency equals 1, just to make sure that we can't see it in there. Thank you. Right, we've got a gap. Right, you can see where the axis has been broken. We've reduced the gap as well to make it tidy. And the final step, as we did before, is just to add a bit of padding around the outside to make it clearer that it's separate from titles and footnotes. Can we go to the next slide, please? And again, we don't need to do quite as much detail in terms of the padding. because of the way that the information is being displayed. So we just in the first top layer we put top and left and right, and then everything else we just put left and right padding. Okay, next. And that's the finished graph. So you've gone from scratch to something that looks fairly close to the original plan. Okay, next slide, please. So, as I was trying to emphasize at the beginning, planning is everything. If you know what you're aiming for, even if you don't get very close to start with, you have some opportunity to mold it a little, to move a little bit closer to your original plan. It doesn't matter whether it's on the back of an envelope or a highly specified blueprint. If you're moving iteratively to it, then it's easier if you've got something in front of you. As new features are added, it's also a learning process. You may do something which initially looks like the right thing, and then discover later on that when you change something else, it has an impact on that original choice, and so you can take it out again. As long as you're learning, then that's good. You'll be able to make use of it later. And finally, as new versions of ODS come out with new versions of SAS, you're getting more and more features. So I'm not aware of a split axis graph being put into the templates at the moment, but given the developers have seen this presentation, I wouldn't be surprised if it appears in a future version. So make use of each feature, and just look out for these new bits that save you a little bit of work next time round. Okay, next slide. And finally, all the code that's been used there is in the website page for download. And my contact details. Next slide, please. And if you want to find out what other things that I'm interested in SAS programming, 2 books here that have already been published, and there's another one coming out hopefully at the end of 2011, which will have details of graphics templates as well as my co-writer writing about the other ODS templates that you use every day. Thank you very much.